Hi everyone, I welcome you to the very first season of the ICPC Asia Pacific Championship hosted in Hanoi, my hometown. My name is Hạnh. It is my honor to present you the solution of the problem group. In this problem, you are given an integer a1 as well as the sequence a2, a3, an. You need to insert a1 into this sequence without changing the order of other elements. In addition, you need to choose some integer k, which is a divisor of n. Then from k groups, by the following rules, two elements belong to the same group if and only if the remainder of their indices after dividing by k is the same. You then calculate the sum of elements of every group, and the target is to minimize the ratio of the maximum of sum of the group divided by the minimum of sum of the group. Here, n is at most 1 million. First of all, let's come up with some very simple solution. Here, we try all the divisor k of n, and for each k, we just try all possible ways to insert a1 into the sequence. Suppose that n equal to 6. And then there are 6 ways to insert a1, forming 6 different sequences, as you can see on the screen. From here, we see that each sequence differs from the previous one in exactly 2 positions. So let's compare the first and the second sequences. We can see that a3, a4, a5, a6 are the same, while a1 and a2 exchange their position. The same thing happens for the second and the third sequences. We see that a1 and a3 swap the position while all other elements are the same. And the similar thing happens at all further iteration, where a1 just swap the position with some element on the right. And from here we see that at iteration we only need to recalculate the sum of 2 groups. Then we can use the priority queue to maintain the group with maximum and minimum sum, which gives us a solution with time complexity of n log n times the number of divisors of n. Unfortunately, with the constraint of the statement, n can have up to 240 divisors, making this solution too slow, and we need to improve it. So, the key observation to improve the solution is that suppose we have 2 different values of k, which is k1 and k2, where k1 is k2 is a divisor of k1. Then choosing k2 is always better than choosing k1. So let's prove the observation. Firstly, we use the 0 base indexes instead of the 1 base indexes as in the statement. With that said, the ith group will contain all the positions x such that x modulo k equals I. So here we take an example where n is equal to 12. Then we compare the 2 possible choices of k equal to 6 and k equal to 3. The table on the screen showing all the groups and all the elements belonging to each group for both the situation. And we can see that the group 0 when k equal to 3 equal to the group 0 combined with the group 3 when k is equal to 6. The group 1 when k equal to 3 equal to the group 1 combined with group 4 when k is equal to 6. And also the group 2 when k equal to 3 equal to the group 2 combined by the group 5 when k equal to 6. From that observation, we have the maximum sum of group when k equal to 3 cannot be greater than 2 times of the maximum when k equal to 6. And in addition, the minimum sum of groups when k equal to 3 is greater than or equal to 2 times of the minimum when k equal to 6. That's why the ratio of maximum of sum of group divided by the minimum of sum of the group when k equal to 3 must always be better than k equal to 6, which means that choosing k equal to 3 is better. Let's take another example. Here n is also 12, but we compare k equal to 6 versus k equal to 2. And in the same way, we can see that each group when k equal to 2 is equal to a combination of several groups of the situation when k equal to 6. And in the same way, we can conclude that the ratio of maximum sum of group divided by the minimum sum of group when k equal to 2 is always smaller than or equal to the ratio when k equal to 6. So once again, choosing k equal to 2 is always better than k equal to 6. All right. From all of the above, we see that we only need to consider the case where k is prime. That's why instead of trying all possible divisors of n, we just only need to take care of the prime factors. And with n is at most 1 million, the number of different prime factors of n cannot exceed 7, which means that this solution is fast enough to pass all the test cases. Alright, this is the end of my presentation. I hope that it is clear enough and it is interesting. Once again, I wish you all the best with the ICPC. I wish you have a good time in Hanoi and enjoy the beautiful country of Vietnam. Alright, thank you so much for your attention and goodbye. Have a nice day.